Hello everyone. So today the objective of this application is to create a goal-oriented autonomous agent that basically decomposes the user query into bounded goals. And in an iterative way, it goes through an approach and a structured route to solve the goal-based solution. So the agent routes through all the LLM calls through a gateway and execute the real-world actions via MCP tool server. So the architecture basically follows the four cognitive role: memory, perception, decision, and action, each with a well-defined boundary and contract, which is governed through the Pydantic schema. So if you look at the overall flow, the user query goes to the agentic loop, right? The agentic loop first reads the memory for a keyword match if the memory has anything. For initial loop, it would be empty. Then it goes to the perception, which actually decomposes the user query and gets the list of the goals what needs to be done, and also responsible to mark a goal for completion. If all the goals are done, yes, it will return to the final answer. If any of the goals are pending, it will go to the next decision, where as a part of next step it will take a decision to call the relevant MCP tool. And this iteration goes through and through to solve the user query until unless we get the final answer, or currently we have configured it for the max iteration of 10. So the architectural component, we have the schema.py, which is the Pydantic class, which is governing all the different Python notebooks. Then we have the agent, which is the front fascia, which actually manages the user query and reflects the final answer. And all the other components like the memory, perception, decision, right? They all interact back to the agent. Memory basically stores in a persistent form under the state folder, right, in a JSON file. So this is something how the memory looks like, right? And if we again go back and see, the perception is basically LLM call, which is taking making sure that the goals are decomposed based on the user query, and if there are any specific attachment needs to be sent across, that is being governed through it. Then we have a decision which basically takes care through all the MCP tool, and basically the action takes care of all the guardrails which we have, and the artifacts if the response from an action, right, or the MCP tool is more than 4 KB, we create in a local artifact which is relevant for the specific loop, whereas memory is relevant for the entire loop to make sure we get the past history as well. Then we have a MCP server, which is basically has a list of 9 um, tools, which web search, fetch URL, get time, read file, create file, and so on. We have got 9 tools. We have a LLM gateway, so that whenever the agnostic way we are being called, the request goes in. So we can show the LLM gateway something like this, where we have all the different LLMs. Since this is based on the Databrick, we have a Databrick LLM, and the recent call was made, and based on the different fallback mechanism, failover order, the request goes to the relevant LLM. Then we see how the flow goes in. So the agent interacts with the memory read. The perception makes the LLM call to bifurcate into the goals. The decision has an LLM call which may call the relevant tool. The action execute the relevant MCP tool based on the requirement. And then the memory is recorded back so that it can be used for the subsequent loop, right? So that's the overall architecture. So we have got 4 queries, right, and each queries are being executed. There are few dependencies, and the queries are the outcome of the result being copied. But just let you show how the result looks like. So the first query is to fetch the Wikipedia page of Cloud Shannon and extract the birth, that rate, birth date, that rate, and the key contribution. So how the iteration goes through, it treats the memory, the procession defines the rules, goals, what it needs to do. If the response from the Wikipedia page is too high, so it is being converted into artifact, and as part of final answer, we are getting the response. What is the birth date, that date, and the key contribution. The B query is more in terms of finding a three family friendly things to do in Tokyo this weekend and check the Saturday's weather forecast and then take the appropriate call. Again, the list of 9 tools, the iteration goes and fetches the three goals to search the family activity, then the weather, and based on the weather condition, define what needs to be done. All the tools are being completed, the response comes back, and eventually in the final answer, we see that the weather forecast is 24-degree, and based on that, they have recommended some indoor and outdoor activities. The third one has two part. The third query is to remember the mom's birthday on 15th of May and set a reminder 2 weeks before. So it has got three goals. First, to store the fact that the user's mom birthday is on 15th of May. Then create a calendar reminder in order to save that detail, and also to create a reminder 2 weeks back. Then the tool calls it, and basically the once the everything is done, then it basically saves the file as uh, mom birthday reminder .txt, which is there in the sandbox, right? Then the query 2 is to a question: when is the mom's birthday? Again, it has goes to, and it has just one goal: to extract that detail, and finally it get that detail May 15, 2026. The final query is about getting to search the Python async IO best practices, read the top three results, and give the short number list and advice they agree on. So it has got the list of the tool. It defined two goals: to fetch the search result and then extract the top three agreed best practices. And after the iterations, it goes through all the action it performs, and the perception marks the goal done when it is done, and then it extract the three details. So this outcome has been copied in the readme.md, right? So that it is more clearer and readable. And this is how we are managing the complete uh, flow of an autonomous agent. I have for crawl and all, we have Tavily. So we have used around 27 today, 37 on uh, DuckDuckGo, and it was a good learning experience. Thank you all.